Good day, guys. We continue from where we stop. We have to show that UP1 FG is less or equals to UP FG. This one that we proved in our last video is for the lower. Where we show that this is this. Let's take this off now. Now, proof. From the reason why I need this one is because of this. Now from here, but now we are dealing with upper Riemann sum, upper Riemann state sum. Now we know that proof. If you look at it by definition, we have our U P F G to be equals to summation I equals to 1 to n mi, that is capital now, theta g x I. Now look at, for every spot here now we are going to define, but let's define our capital M for that region. For partition P now, for partition P, let's define this now. Let's have M star for that region. It will be supremum, such that it is between this and this, which is what sk minus 1 less or equals to x, less or equals to what x star. Do you get it? Now M star is what supremum. M star will be from here to here. We have f of x is equals to x star less or equals to x less or equals to sk. We have this. Now for partition, this for partition P1. Now for partition P, let's just define this one is just one definition. That is, we are going to have mk equals to supremum of fx, and we have sk minus 1 less or equals to x less or equals to sk. Now look here. If you do this now, between this and this, what will be our supremum? It will be what? X star. Between there and this. Now, if you remember the definition of supremum, you will understand this stage. Now, between this and this, what is the supremum? This is the supremum. Are we? Now, we want to define the upper Riemann state sum for every point. You can see our interval now. For every point on this partition. Now for partition P1 now, we are going to have UP1 FG, because to now we are going to have summation I equals to 1 to, from here we start from here 1 to k minus 1, then we are going to have mi theta gxi. Now plus, when we now get to this region, we define our M. We want to define the upper Riemann state sum for this. Now it will be M star G of, the M star that you define is for what range? It's for this and this. It will be G of X star minus G of sk minus 1. Now plus the next one will be this and this. So it's now be M star G of X. The M star is for this. So K then minus G of X star. Now plus, the next one will be K plus 1 to this. So that will be summation I equals to K plus 1 to N. Mi theta gxi. Now you get it. Now for for P alone, it will be summation P, the upper Riemann state sum. It will be same way. You should have understand this by now. Delta gxi. Now plus look at this interval for P now. Is this where they introduce new this thing, abi? So we are going to have I equals to 1. Now, no, it's not I equals to 1. Sorry. It will be mk gsk minus gsk minus 1. Do you know where that is coming from? It's coming from here. It's coming from here. This, I already defined the mk for this region, right? Now, then plus, you know, for partition P, then after this, look at, we are only having this, then from here, so we are going to have summation I equals to k plus 1, then I delta gxi. Now, the way I've been explaining this, to know if something is bigger or lesser. Now, if you have, from the previous example, if you want to know that this is greater than this or this is lower than this, let's assume that we have A and B. You know, if A minus B is equals to positive now, it shows that this implies that A is greater than B. Abi? If A minus B is negative now, this implies that A is less than what? B. Abi? Now, let's have something like this. U P1 F G minus Abi? Now, we are subtracting this from this. Abi? Now, let's subtract now. You see that we have this, and we are subtracting this. We cancel this, Abi? And this, we also cancel this. So, we are left with what? We are left with M star G X star minus G SK minus 1. Now plus, you know, this will be M star star, capital M star star G SK G X star, Abi? Then, you know, we are subtracting it from this, so it will be minus MK. Now, in between this, I want to introduce 0. Okay, wait, let me write this stage first. SK minus 1. Now, do you get it? Now, from here, look at this will stop having equals to. Now, this region, you know why we can call this delta GX star. Now, I already explained that. Now, plus M star star delta GXK. The reason is this minus this. So, just if you have this kind of expression and GX, you notice GX2 minus GX1. I mean, so if you have this now, what is this instead of we go backward with 1? I mean, now if you have this kind of, okay, let me bring out this thing. Look at this. If you look at this now, delta G X star is telling us that we go back, subtract, Abi, which is equal to what we have here. Which is equal to what we have here. You can see, we go back. Now, you know it is minus MK. Now, you want to introduce 0. GSK minus GX star plus GX star minus GSK minus 1. Now, this is the 0. Yeah. So, if you are going to have M star, I'm writing this back. Delta, I'm writing this GX star plus M star star delta GSK sk. Now if we bracket this, we know what this is, and we know what this is. Now using this to multiply, to open the bracket, mk, you know this one is delta gxk, you should know where this is coming from. Now minus mk, you know this is delta gx star. Now let's factorize. Now you see that we have m star. If you look at this, they are equal, minus mk, we have delta g x star. Now the next one is, look at these two, they're having delta gsk, so it will be plus m star star minus mk delta g xk. Now you have this to this, right? Now you know we have this stuff here. What is m star? Look at what we have. Look at what is m star. M star is equal to x star. What is m star star? Sk. What is mk? Sk. So we are going to write it now. It will be, look at, since m star is equal to what? X star, and m star star is equal to what? Sk, and mk is equal to what? Sk. Now something will happen. Now look at, let's have this number line now. You know we have sk minus 1, x star, and xk. You can see that x star is less than sk. So our m star now, you know, coming back to this expression now. Let's have this. You know we have m star mk. You see, m star is less than mk. So if it is less than mk, it's just like having, if 2 minus big number, it needs to be negative 3. You understand? So if m star, look at, it's just, we are having m like this. So what do you think it's going to give us? It's going to give us a negative value. So the whole of this expression is giving us what? A negative value. So let's also have this m star star minus mk. You know they are equal, so this will be 0. But and also delta g x star will be positive, because if you do this minus this now, it will be positive. So look at this, delta g sk2 will also be what? Positive. So the whole of this expression, you know, if you put this one, which is the negative times positive, since this one is positive, negative times positive, like we are going to have something like this. You know, it is u p1 fg minus u p fg, which is, they have equal. You know this one is negative. The result we have for this one is what? Negative. Let's put negative there. And this one is what? Positive. This one, we can say 0 or positive. Anyone want to say. But let's say 0. You know, 0 multiplied now. We're having this. So what this is trying to tell us that the whole expression that we have here is less than what? 0. So far it is what? Negative. You know, negative times positive is what? Negative. So this implies that this implies that this one is 1. If this implies that u p1 of f g is less than u. Now we can put equals to if they are all equal. So that's what put equals to. You get it? So you get the normal and this thing. You can see from where we start. We've proved this now. So thank you.